Okay, this is the second part of 3.3, because the first part of 3.3 is a review from last year where you're just subbing in values for, in the homework you're just subbing in values for the Celsius and Fahrenheit, and then you're solving a standard form for y. And I know that if you're an 8th grader last year, or if you're in my algebra class this year and you had 7th grade last year, I know you guys already learned how to do that. So I'm going to focus the majority of the time on this lesson on literal equations and how to rearrange them. Literal equations are just math formulas that are used for a specific purpose. Now, literal equations you've used before, you just didn't know were called this. It was going to be things like volume formulas, distance equals the rate times time. You probably used that in science class, area, that kind of thing. Okay, how do you solve for a given variable? Well, the strategy I'm going to show you is to make a list of all the operations that are happening to that variable in the order of operations, and then work backwards and opposite through that list on both sides. Now I'm going to start with an example of something you already know. This is not in the notes. Okay, 2x plus 5y equals 10. Okay, and you guys are already pretty good at solving for y. You're used to saying, okay, 2x goes on the other side, so I'll subtract it. 5y equals negative 2x plus 10. We're maintaining our y equals mx plus b form. Then divide both sides by 5. Okay, and you get y equals negative 2/5 x plus 2. What you don't realize is you actually followed the steps that I'm going to show you today for other kinds of equations. You are already following these steps. Okay, so what we're solving for is y. So I'm going to go through order of operations and see what's happening to y. Is y in a parenthesis? Nope. Does y have an exponent? Nope. Is y being multiplied by something? Yes. Y is being multiplied by 5. Okay, is it adding or subtracting with something? Yes. It is adding with 2x. Okay, now we're going to start working through these steps but backwards and opposite. So the first step you guys did was subtract 2x, which is the backwards and opposite of the list we just made. Then you divided by 5, which is backwards and opposite of the problem that you already have done. Okay, so you're already doing these things, you just didn't realize that you were, and the same strategy can apply to lots of other formulas. So let's look, we're going to look, these formulas aren't about anything, I just made up some random stuff, okay? So let's say we're solving for b. Well, what's happening to b? Is it in a parenthesis? No. Exponent? No. Multiply, divide? No. Adding. Okay, the only thing that's happening to b is it's being added with a. So the opposite would be to subtract a. So I will subtract a both sides, and b equals 2c minus a. All right, let's do a little bit more complicated one. Let's say we're solving for d. What's happening to d? It's in parentheses. Parentheses is first in order of operations. What's happening with d in the parentheses? It's subtracting a. Okay? The next thing that's happening after subtracting a is multiplying by 3. Okay, so those are the only two things happening. Now we're going to reverse an opposite. So instead of multiplying by 3, we're going to divide by 3. And this feels weird because you're used to distributing that, and that won't help us to get d by itself because those are all, we have mostly letters, so that won't help us. So dividing by 3 on both sides, makes those cross out, and I bring d minus a down. But since it's all that's left, I don't need the parentheses anymore. And then 4g over 3. I don't know g. I can't really divide this. I just leave it the way that it is. All right, let's do my next opposite step. Subtract a. I'm going to add a. Add a. Add a. Okay, so d, we've got d by itself now. We're going to keep 4g over 3 as a fraction, and we're just going to write the add a as a horizontal add-on. And we're done. Okay, so list out the steps and then kind of connect them to show that you're doing them in opposite and reverse order. Okay, F equals ma. If you're interested in physics, that's force equals mass times acceleration, but I don't care if you know that or not. Let's say I'm solving for m. Well, what is m doing? It is multiplying by a. Okay, then that's the only thing that's happening, so the opposite is divide by a. And I get m equals F over a. All right, the next one. All right, if you don't recognize that, that's okay, but it's Einstein's theory of relativity. Energy equals the mass times the speed of light squared, I think. Not really an Einstein physicist. All right, if let's say I wanted to solve for C. What's happening with C? Well, it's not in a parenthesis, going in order of operations, but it does have an exponent. Okay, C is squared. Then C is multiplying by m. Those are the two things that are happening. Let's go in opposites. Okay, I'm going to divide by m. So C squared equals E over m. Now the opposite of squaring something is square root. So I'm going to take the square root of both sides. Okay, remember square root is like a check mark and a long division had a baby. So C equals E over m with a square root. Okay. All right, let's do the next one. And the only thing I can solve for is r. All right, what's happening to r? R is multiplying by 2 and pi. Because we're multiplying by two things at the same time and they're the same operation, we don't have to list them as separate steps. So we can divide by 2 pi. You don't have to list it's multiplying by pi and it's multiplying by 2. You don't have to list them separately. You can list them together and you can divide them together. 2 pi, 2 pi. So r would equal C over 2 pi. V equals pi r squared h. Let's solve for h. You know what? I want to skip this one. There's one. I don't want to get this video too long. Let's go to the Celsius Fahrenheit one. The only variable I can solve for is f. All right. So if I want to solve for f in parentheses, we're subtracting 32, and then we're multiplying by 5/9. Okay, fractions are tricky, and we're always going to do fraction multiplication a little bit different. Okay, and we're still going to do something that's opposite, but it's not the operation that's going to be opposite. Okay, we could say divide by 5/9, but then we're going to have a complex fraction. If you see this problem on your Regents exam, it's going to be a multiple choice, and I guarantee you they're not going to write it as a complex fraction. So I got to show you how to make it not a complex fraction. So We're not going to make the opposite thing be the operation. We're going to keep the operation the same. What we're going to make opposite is the fraction. Remember that if you multiply by a reciprocal, in other words, the fraction flipped upside down, that's what cancels the fraction. Okay, so I'm going to multiply this, and I'm going to squeeze it in here, by 9/5 on both sides. So that's what cancels this fraction on the right-hand side, and I bring f minus 32 down. On the left-hand side, I have 9/5 times c. Okay, then the opposite of subtracting 32 is add 32. So I will add 32 to both sides. And I get f equals 9/5 c plus 32 to transform that equation. Okay, I want to do only one more from this packet. I want to do a equals 1/2 base times height, and let's solve for h. And the reason I want to do that is I want to reinforce the fraction one more time, and we're going to list those steps separately. Remember in the 2 pi question I said we were multiplying 2 and pi, we didn't have to list those separately. That's because they're both whole numbers. A fraction I'm going to want to write as 2 separate steps. I'm going to want to address the fraction first. Okay, so it's multiply by b, multiply by 1/2. Okay, let's get rid of the fraction. We're going to, again, remember with a fraction we don't make the operation opposite, we flip the fraction. So I'm going to say multiply by 2/1 because that flips the fraction, but we all know that that really means 2. Okay, so I multiply by 2, squish it in on both sides, and I get 2a equals, that cancels, base times height. And then I'll do this as a regular divide by b. Okay, then there's one on the homework that I want to make sure I go over, so I'm going to pause this. Okay, so number 20 on the homework, this is, I don't know, you should have done area of a trapezoid at some point in your life, but let me just draw you a picture so you understand what's going on here. Because those subscripts of 1 and 2 on the b, okay, numbers really small that look like exponents but down low, those are called subscripts. So in a trapezoid, the top base is b1 and the bottom base is b2. Okay, and then the height. All right, and they're asking you to solve for b1. Now you've seen me highlight what we're solving for. That's a good little strategy. Okay, the 1 and the 2 in front of the b's. Since these are literal equations, the letters that are in them are not random. They stand for the things they are. Like h is for height. Since there's b stands for base, but there's 2 bases and the bases are different. So they just put a little 1 and a little 2 next to them so that you know that they're the same kind of number, but they're not the same physical number. Like they're not both 5. One's going to be smaller, one's going to be bigger. Okay, so what's happening to, let's make a list. All right, we've got a equals 1/2 parenthesis b1 plus b2 h. Let's make our list of what's happening to b1. Well, it's being added to b2, multiplied by h, and multiply by 1/2. So let's go through that in opposite direction. Remember fractions, we're going to keep the multiply but flip the fraction. So we're multiplying by 2/1 or just 2, same thing. So I've got 2a equals b1 plus b2, still in parentheses, times the height. Then I can divide by h, both sides, and I get b1 plus b2. Now that there's nothing else on the right-hand side, I don't need the parentheses anymore. 2a over h. Then lastly, subtract b sub 2. And I've really over-calculated how much space I needed. So b1 equals 2a, over h minus b sub 2. I know that's really hard to read. I severely miscalculated how much space I needed there. Okay, so that was a problem that came up in class when kids were working on it, if you wanted to see it one more time. All right, thanks guys. See you next time.